right, so first thing, that is the Greek letter sigma. It tells you that we're working with a sum. And what is a sum?
Adding things.
Adding a bunch of things together.
Pro stats.
Okay, do you remember this symbol last year? Well, and in algebra 2 with a series? Okay.
What? I hated series. No, I couldn't do the same. I forgot everything.
Okay, so here's our summation notation. We start here at k equals something. Okay, that's our lower limit. And we end up at n. Maybe it's n, maybe it's an integer. Okay? So this tells you it's a sum. This tells you where to start. This tells you where to end. And this tells you what you are adding over and over. So you're going to plug in your k values into f of k, and you're going to add all of them up until you plug in your n value. So this is just kind of a summation of what I just said. Okay, we need to substitute integers. Here, this looks a little different. This says we start at A and we end up at B. It doesn't matter if this is a K, if this is an I. It doesn't matter where we start and end. We're going to be in the positive integers. Okay, but it can start and end really anywhere within those specifications. You're going to substitute integers until you get to your e value, and you're going to add them together. So what does this mean?
I'm going to plug in 1 through 5 and k squared and add them up.
Okay? 1 squared plus 2 squared plus 3 squared plus 4. What about this one? The sum from k equals 3 to 8 of 7. We're going to add 7 together 6 times because you plug in 3, 4, 5, 6, 7, 8. So it ends up being 6 times 2. Okay. All right. So let's find some sums.
That's good. Okay.
Okay, k equals 3 to 8. The sum of
6.
2k. So when we plug in 3, we get
6 plus 8 plus 10 plus 12 plus 14 plus 16. That's it.
okay. We plug in 2, 3, 4, 5, 6, 7, 8. Okay. Let's see if we can take it up.
Show the basis.
What is that? Is that a calculator? What is that? Alright. Let's do the second one. We plug in 2. 2 times 2 times 2, right?
8.
So we get 8 minus 3, which is 5. Plus, when we plug in 3, what's 2 times 9? So we get 18 minus 3. And then when we plug in 4,
No, calculate. What is that?
49. Okay.
What?
Okay. Now, if you're adding things together without a calculator, what would you group together first? 32 and 8 gives you what? 40. That's easy to work with, right? Group things together that add to 10 or subtract to 10 or whatever. Okay? Okay. All right, this one's fun, right?
Oh yeah.
Okay. Our first term, we plug in 1, so we get k times, what is the sine of pi over 2? Agree? 1. Plus, our next term, 2 times, what's the sine of 2 pi over 2? 0. Plus 3 times, what's the sine of 3 pi over 2? That's all I hear. -1. Okay. Is it okay that our sum is negative?
Yeah.
Yes, it is completely fine. Okay. However, we are not going to plug negative numbers. These over here, k equals 1 to 3, those will always be positive. Okay, and we will always increase by just an integer when we plug it. Okay. Now, notation-wise, when we talk about the general form, if this is your sum, okay, b sub k is the sequence that you're adding, and so our terms are b sub 1, that means I'm plugging 1 in, b sub 2, that means I'm plugging 2 in. Okay, I don't want you to get confused by notation when you see it. Okay. Everyone okay with that notation? Okay, let's talk about some properties. If we have a constant inside of our sum, we can pull it out and multiply it later. Does that seem reasonable? The second one, well, which really relates to this third one, B and C basically look the same. If we have addition or subtraction within our summation, we can break it apart into summations where they still start and end at the same place. Okay? There we go. examples. Up here we have the sum from k is 1 to 3 of 2k. Right? That 2 inside, we don't have to keep there. Alright? It's a scalar multiple, if you will. So we can pull it out. Alright? And basically we have 2 times 1 plus 2 plus 3. Over here, we have the sum from k equals 1 to 4, k minus k squared. This is the same thing as k equals 1 to 4 of k minus the sum as k equals 1 to 4 of k squared. So here we have 1 plus 2 plus 3 plus 4 minus 1 plus 4 plus 9 plus 15. Okay, so if I'm doing this without a calculator, automatically I'm going to say 1 minus 1 and 4 minus 4, and then this adds to. Okay, now I know this seems kind of easy, boring. Okay, we're eventually going to relate integrals back to these summations. Okay, and all the properties that we do with the summations, we can also do with our integrals. Like we were able to pull a constant out of our integral, correct? We were able to separate into 2 different integrals if we wanted to. Okay, these concepts, they're related to each other. All right. Some shortcuts that you can use. Okay, if you have really large sums, 1 to 30, you really want to sit there and plug 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way to 30? Probably not. Okay, here are some shortcuts if you are adding, if you are doing a summation of a variable to the first power, second power, third power. I might have to look that up just to be sure, but whatever it was. All right, we ready to use these? We're ready, but we don't want to be ready. Okay. have the sum from k is 1 to 23 of k. What was our shortcut if we just are adding up k? Give it to me in general terms. N times n plus 1 over 2, right? So we're going to have 23 times 24 all over 2?
Yep.
Okay. 24 divided by 2 is 12. What's 23 times 12? Right?
Yeah, so I got it. I don't know, you got it. I subtracted one.
Is that right?
I always have to do that. I'm not making that.
What Brady was doing for his shortcut, he had 23 times 12. So he took 20 times 12 and then 3 times 12.
I took 23 by 10 and then
I would have
23
just
by
multiplied by 2.
Oh,
added.
Well, I mean,
okay. Okay. 1 to 7 of k squared. Okay, our shortcut for k squared is n. So what's n?
7 plus 1.
Times n plus 1 times 2n plus 1. 15 all over 6. Potentially. Is this really that serious? What's 7 times 8? 56.
I was gonna say 15. Yeah. We take out 2 out of the
Okay, so 6.
Make that 4 and make the 15 3 or 5. Yeah, 5.
5. Because this is 2 times 3, so we can cancel a 2 here and a 3 here. So 4 times 5 is 20 times 7. Huh? Okay, and then the summation of k is 1 to 6 of k cubed. Okay, that shortcut is the same as the k shortcut except squared, correct? So n is 6, n plus 1 would be divided by 2 and then squared. So 6 divided by 2 is 3 times 7 is 21. Squared would be 447. Brett's very good at mental math.
Do it right now.
Plug for math club. Wednesday we're having a math club meeting, and we're gonna do a competition. It's basically a mental math game. So. Don't be cool.
Yeah, don't be cool with that.
like, say, 1 and,
Okay, here we go.
oh, I think that, like, I thought it was like a pun. Like, not,
Okay. So this is what I would do on this one. Could we use shortcuts if we rewrote it?
Yeah.
Okay. Let's make this k squared plus k. Is that legal?
Yeah.
Can we use a shortcut here?
Yeah. I don't know.
All right. Our squared shortcut.
Is
N times n plus 1 times 2n plus 1 would be
61.
divided by 6 plus our k shortcut
30.
n
31.
times n plus 1.
11.
I'll let you use your calculator. Hmm?
Because you were like smiling, screaming, you're gonna be down like this.
We kind of said weird.
Your face is really strange.
I'm a funny looking gal. Yeah. Anybody have something for me?
I know, I don't want to be here.
Same.
Oh, okay. We'll jump right on this. You're at 5%.
9,000.
Yeah. That.
9,920. You disagree. Alright. Now let me teach you how to do this on your calculator.
Okay. I got it. I don't know.
How many of you have 83s?
Zing.
Okay. First of all, if you have an 84, you can go to math and arrow down. It is on your 84.
Wait, you have 84 and then 80?
You want to go to 0. Okay? If you go to math and arrow down to 0, it gives you a blank summation that you just have to fill out. And you can use X's. It's okay to use X instead of K in your calculator. Now, if you have an 83, it's a little bit more complicated.
What if you have a cat?
Then you might have to play around. Do you have your manual?
Just
Okay.
things like from 1994.
Okay. Well, mess around a little bit, and if you can't figure it out, maybe I can help you. Okay. So if you have an 83, you can go to second list, and over in math, there is a sum. Yep. Then we're going to sum up a sequence. So then you're going to go back to list, and in operations, we're going to go to a sequence. Okay, this is all in second list. Okay, so we're going to sum up the sequence. Our sequence is k times k plus 1, so I'm going to write x times x plus 1. Okay, and then we're going to write a comma. Our variable is x, comma. We're starting at 1, comma. We're ending at 30, comma. And we're going to go and we're going to plug in numbers in increments of 1. Okay. 84s, you have it really nice. Don't you? Sorry, 83s. Okay. Questions on your calculator? Perfect. Couple more slides. Okay. Here I have this. You recognize this, right? Okay, this is the shortcut for adding up k squared from 1 to n, which is what I have written over here. 1 squared plus 2 squared plus 3 squared. This is just correct? Okay. This is what we call closed form. This is what we call open form.
They say that side is closed.
Yes, please turn on. Okay? You may be asked to write something in closed form, so you need to know that that means this as opposed to this. Okay? So for example, we want to write this in closed form. First of all, we can't leave it as 3 plus k the quantity squared. Okay? But we know what 3 plus k the quantity squared is, don't we?
9 plus 6k plus this way.
Okay. We can rewrite our binomial squared as this, and then we can break it up into 3 summations, where we have the summation from k equals 1 to n of 9, plus the summation, well, we can pull the 6 out in front and leave k inside because we have a shortcut for that, don't we? And then the summation of k squared. Okay. If I sum up from 1 to n, 9, what do we get? 9n. We're gonna add 9 over and over and over and over n times. Multiplication is repeated addition. Right? Plus, here I have 6 times, I'm summing up k from 1 to n. Well, what's that shortcut? Right? And then we have the summation of squares. N times n plus 1 over 2n plus 1 times 1 plus 1 all over 6. And you can leave it. Any questions? There's your homework. And you have time to work on it.
Yay.